Let's learn about the autonomic nervous system. The autonomic nervous system has two divisions. The sympathetic division responds to stress and activates the fight or flight response. The parasympathetic division activates the rest and digest response during non-stressful conditions. The sympathetic nervous system dilates the pupils, speeds up the heart rate, inhibits the salivary glands and bladder, dilates the bronchioles, inhibits the sex organs, inhibits digestion, promotes the release of glucose from the liver, and promotes the release of norepinephrine and epinephrine from the adrenal glands. The parasympathetic nervous system has the opposite effect on organs. It works to constrict the pupils, slow down the heart rate, promote salivation, stimulate the bladder, constrict the bronchioles, stimulate the sex organs, promote digestion, and stimulate the gallbladder to release bile. The sympathetic nervous system is also called the thoracolumbar division of the autonomic nervous system and is located in the thoracic and upper lumbar areas of the spinal cord. Neurons from these areas move to a series of ganglia called autonomic ganglia. Neurons located between the spinal cord and ganglia are called preganglionic neurons, while neurons exiting the ganglia are called postganglionic neurons. The postganglionic neurons innervate the organs. Here's a simplified view. The preganglionic neurons extend to the autonomic ganglia, and the postganglionic neurons innervate the target tissues and organs. Most of the postganglionic sympathetic neurons secrete the neurotransmitter norepinephrine. The neurons innervating sweat glands secrete acetylcholine. Epinephrine is also known as adrenaline, while norepinephrine is also known as noradrenaline. Sympathetic neurons secrete norepinephrine or both. The neurotransmitter floats across the synaptic cleft to the receptors on target cells in tissues or organs. The receptors that respond to norepinephrine or epinephrine are called adrenergic receptors. There are two main types of adrenergic receptors, alpha and beta. These can be further subcategorized into alpha 1 and alpha 2, and beta 1 and beta 2. The alpha 1 receptor is found in all organs innervated by the sympathetic nervous system, except the heart. These receptors work to promote vasoconstriction. Alpha 2 receptors are found in presynaptic adrenergic nerve terminals and on platelets. Alpha 2 receptors inhibit norepinephrine release, so they work to regulate norepinephrine. Beta 1 receptors are found in the heart and kidneys. They work to increase the heart rate and force of contraction. They also promote the release of renin. Beta 2 receptors are found in all sympathetic organs except the heart. They work to inhibit smooth muscle contraction, such as in bronchodilation. The parasympathetic nervous system is also known as the craniosacral division of the autonomic nervous system. Here, the preganglionic neurons do not synapse in autonomic ganglia, but extend to ganglia near the organs. Here is a simplified diagram. Preganglionic neurons extend to ganglia near the organs with shorter postganglionic neurons innervating the organs. The postganglionic neurons secrete acetylcholine. Cholinergic receptors on cells respond to acetylcholine. There are two types of cholinergic receptors, nicotinic and muscarinic. Nicotinic receptors are located in the autonomic ganglia and work to stimulate muscle contraction and glandular secretions. Muscarinic receptors are located in the cardiac conduction system, smooth muscle, exocrine glands, and organs innervated by the parasympathetic nervous system. Muscarinic receptors work to decrease the heart rate and force of contraction. They also promote smooth muscle contraction and glandular secretions. Stimulation of muscarinic receptors results in the classic signs of parasympathetic activity, which is why they are affected by a number of medications. I hope you've learned something about the autonomic nervous system, and see you next time.